So I'm just going to do a quick demonstration of how my final project works. For my final project, I made a compression application that can implement two different compression algorithms. The first of which is run length encoding, which takes in any input file and interprets it as a string, and say the input string has repeated occurrences of a letter. For instance, if it's AAABBB, it saves it as A3B3, and that's how it does its compression. So this is a sample file that I would like to compress. I want to mention that not all files would work well with RLE compression. Files with repeating letters, such as this file that I made, rletest.txt. It's originally 1,633 bytes, and we go in and compile. I implemented the front end of this project using Qt, and we put in compress with RLE and choose the file that I mentioned. Okay, and then it says compressing, and then we go back to final project over here, and we see that it's formed an rletest.rle file with the .rle file extension, just like how a regular file compression application would work. If we get its information, we see that it's only 454 bytes as opposed to the original 1,633 bytes. I also implemented a decompressor, so if I choose to decompress with RLE, first I need to enter the file extension of the original file, so it knows what kind of file it's dealing with. I considered implementing it with a metadata, but then it ended up being too complicated for me to implement. So we pick the file rletest.rle. It's decompressing, and we go back in, and it formed an rletest2.txt, which once we open, we realize that there is no loss in the information, and that's because RLE is one of the compression algorithms that's lossless. The second compression algorithm that I implemented is also lossless, known as LZW compression, and again, this is not well suited to every kind of file, but would work really well to files that have recurring patterns in them. So how this compression is implemented is it's far more complicated than RLE in the sense that it uses a standard container. I implemented it using std unordered map, and it acts as a dictionary and stores patterns that it sees in the input string, and then recognizes the patterns as they appear later on in the file and assigns codes to them, and that's how LZW compression works. So again, we look at the original size of the file, and it's around 2,500 bytes, and we will attempt to compress it. Compress with LZW. Test lzw.txt. It's compressing, and then we want to decompress the file, obviously. First, let's see how big the compressed file is. The compressed file nearly half the size, it's only 1,500 bytes. And now, to decompress it, again, I required the extension from the user, and go in to final project, lzw.test_lzw.lzw, open it, decompresses, and we have lzw3.txt, and as you can see, it's the same as test lzw. In other words, this is also a lossless compression algorithm, and none of the data from the original file is lost. And that was my project.